Greetings of the day. I, Kuba Bukhari, student of civil engineering at lovely Professional University, Punjab, welcome everyone who has been with us and who have joined in the seventh session now. That is for Enviro Web Talk 2021, an international environmental engineering webinar series. I will be your co-chair for the session. Thank you for joining us today. Dear Dr. Izharul Haq Farooqi sir, on behalf of School of Civil Engineering, Lovely Professional University, I welcome you for your session on the topic Emerging Contaminants in Water and Wastewater. The session is chaired by Dr. Pushpendra Kumar Sharma,
Thank
Professor, Lovely Professional University, and will be co-chaired by me. I request my faculty member to take over the session as chair and start the proceedings. Over to you, Dr. P.K. Sharma.
Thank you very much. It gives me an immense pleasure to introduce Professor Izharul Haq Farooqi, sir, to our audience who have joined on this Google Meet platform. Professor Farooqi has been working in environmental engineering field for the last 31 years. The area of specialization are water and wastewater treatment, including biological treatment, biodegradation of toxic waste, corrosion control. Teaching interests include biological treatment of wastewater, environmental chemistry and microbiology, industrial water treatment. Dr. Farooqi has published 103 papers in international and national journals and conferences, having citations more than 1300, H index 20 and I-10 index as 35 the great. Some of the Water Science and Technology Elsewhere, Journal of Hazardous Waste, Waste Management Trends in Analytical Chemistry, Journal of Cleaner Production, Bioresource Technology Elsewhere, Journal of Environmental Science, Taylor and Francis, Journal of Environmental and Technology, British Corrosion Journal, American Journal of Corrosion, Journal of Corrosion Prevention and Control, and Anti-Corrosion Methods and Materials. Apart from this, Dr. Farooq has presented research papers in international conferences in USA, Switzerland, Norway, Netherlands, Malaysia, Singapore, Italy, Saudi Arabia, Denmark, London, and different places in India. Dr. Farooqi has delivered more than 100 invited talks. He has mobilized a large amount of consultancy for the department and has established an state-of-the-art advanced environmental engineering laboratory through research projects and has been an expert member in the various national bodies. Dr. Farooqi has supervised 6 PhD scholars and another 7 under supervision. Dr. Farooqi has supervised 69 MTech dissertations. Besides, Dr. Farooqi has received 4 research projects from different organizations. Dr. Farooqi is currently serving as an in charge of the environmental engineering section of the department. Dr. Farooqi has participated in the Ministry of Human Resource Development MHRD's leadership for the academicians program LEAP and has attended 1-week training program at Monash University, Melbourne, Australia under the same program. Also received Young Scientist Award Council of Science and Technology in 2002. It will take a long time if I explain many things about him. He is such an achiever. Now I hand over the session to our guest to deliver talk on the topic emerging contaminants in water and wastewater. So handing over to you, sir, please.
Thank you very much, Dr. Pushpendra Kumar Sharma, for a very nice introduction. Though I don't deserve it much, but you have very nicely introduced myself. So I've been working on water and wastewater. So today I shall deliver a talk on the emerging contaminants which are present in water and wastewater. So I would like to request the chair and co-chair, please inform me on my phone if the link goes off. Sometimes it happens that because of connectivity issues, we continue to speak, but the link goes off and the participant doesn't receive the signal. So whenever such thing happens, please call me, and my phone is with me. And now I would like to ask you whether my screen is visible to you or not. All of you, please.
Yes, sir. Yes, sir. It is visible. And
Yes, sir. It's visible, loud and clear.
And I'm audible. I'm
yes,
audible.
yes. Yes, yes,
My
sir.
Okay.
voice
Yes.
is
Yes, sir.
clear. Okay.
Yeah, you are audible.
Thank you
But
very much.
one thing you can do, you can hide this bar, which is there on your screen. Uh, there is a hide option.
This one.
No, no, no.
This one. Okay.
Yeah. I think now you can go back to your presentation. Uh, I think you have
Which
done.
one hide? I just
I think you stopped sharing. You can again go back and share your presentation.
okay. Let me. I should first stop. Mm, Pressing now. Okay.
So excuse me, till then there is one announcement during the session. If you have questions, you can put the same in the chat box, or you may ask it at the end of
Yeah.
yourself. Your questions will be taken care by the expert at the end. Till then, please keep yourself muted and your video also muted. Thank you.
Yeah. Use that hide option. Yes. Perfect. Perfect. Now it is okay.
Okay. So good afternoon to everyone. Today I shall discuss about emerging contaminants in water and wastewater. So just to start that, we all know that water covers the three-fourths of the Earth's surface, and it supports life and is very critical for the survival of the industry, agriculture. And the man-made activities, has deteriorated the water quality of our sources. And let me tell you that only 0.8% of the fresh water is available for us. And we have, through our own activities, have dumped waste in this, and the quality of the major surface waters in our country is not very good, and we need to have a very good treatment to supply this. So the legislations are there. There are legislations which says that one has to discharge the wastewater after giving so much of treatment. But many of you must be knowing that in our country, only 35% of the sewage is collected through sewer lines, and nearly 65 to 70% of the sewage of the country goes to rivers without any treatment. So this is something very, very alarming, that we are not able to, uh, treat all of our municipal sewers, wastewater. And the main thing I should say that the municipal wastewater is, causing more and more threat as compared to industrial wastewater. Why? Because,
Excuse me, no, I think no
industries have
PPT,
their own uh,
no PPT.
industries have their own uh, treatment plants, so they just do all the treatment, and moreover the flow rate, the amount of the flow is also less in industries. But again, the
Excuse me, sir,
sewage,
no
that
PPT, sir.
the volume of the sewage is very large, and that contains all the pollutants which makes our river water quality poor. So the biological quality components, or the general components, or the specific pollutants, each and everything you can find in our water bodies, and the status can be defined with the help of such parameters. So now coming up to the safe drinking water, that is, it should be free from pathogenic organisms. It should be clear. It should not be saline. I'm just revising a few slides before I go to actual topic. It should be free from offensive case skin smell, and it should be free from compounds that have an adverse health effects on human health. and
Sir,
also
PPT is not
compounds that
visible.
cause corrosion of wood.
PPT, hello sir.
Yes. G, PPG is not visible.
Yes sir.
No, no, PPT is visible. Only thing is that you have to actually go to Dr. Farooqi presentation and pin to screen. Use that pin to screen option, and then it will be visible. So
No,
please don't
you're
disturb the experts. It is there. It is there. It is visible. But the only thing is that they have to pin to screen. Use that pin to screen
Asha,
option. Then only you will be able to see the presentation.
so it is clear from my
Continue,
side.
sir. Please continue.
Thank you.
Yeah, it is clear from your
Thank you
side.
very
Only
much.
thing is that
So,
they have to pin to screen. Yeah.
okay.
there is no issue
Thank
from
you.
your side, sir. You continue.
Okay. Thank you. So, just to revise things, like there are certain waterborne diseases, and some of them are bacterial, like cholera, typhoid, dysentery. Some of them are viral, like hepatitis A, which is very common after monsoons, polio, and many cities have this precaution diseases. In Aligarh, this maybe dysentery is very common, and diarrhea is one of the most killing disease in African countries also, because of the poor water quality which they take. So we say that in the last decade, the number of children which were killed by diarrhea exceeded the number of people who have lost their life in armed conflicts since Second World War. So we can say that in those countries, we are living in a country where the quality of water is good, but in African countries and other countries, the poor quality of water, is in every 8 seconds a child dies from drinking this contaminated water. Also in our country, also there are places like in Rajasthan and other places where there is scarcity of water. So this was just to see what is the importance for us. If in on one day your submersible doesn't work, so how difficult the life becomes. No water, we can't survive. Okay, so we have to keep our resources, our reserves clean, and of course sustainable. So before going to the emerging contaminants, let's discuss some important contaminants like nitrates. The source of the nitrate is again from agricultural fertilizers, nitrogenous materials, sewage pollution, and also because of biological nitrification of ammonical compounds. So it affects infants. It causes blue babies where the baby turns blue. Why? Because the oxygen of the blood is being consumed and the baby turns blue and the death occurs. But the limit is quite high. 45 milligrams per liter is a permissible limit for nitrates. Fluoride has been a matter of concern for many years in our country. And in Uttar Pradesh also, I am a member of this rural water supply scheme. So I received many reports from various villages that the water contains very high amount of fluoride, 4 milligram per liter, 5 milligram per liter, 3.5 milligram per liter. So we have to provide on-site treatment facilities for them. So fluoride is very widespread in our country, and the maximum permissible limit of fluoride is only 1.5 milligrams per liter. But we have seen in Rajasthan, some places I have personally, collected water and analyzed it. I found as 6.5 milligram per liter fluoride in that water. So can you imagine what will happen? Like if the long-term consumption of such concentrations above permissible limit can lead to very dominant processes. One is the dental fluorosis, that is the mottling of tooth enamel, and second is the bone fluorosis, which is skeletal deformation. Just a minute. Ji, hello. Uh, let me check. Let me check whether it is gone or not. Oh. So what was the last slide? Okay. Okay. Thank you very much. I don't know what happened because the neck speak is very good. Yeah. There's no issue with the neck speak. So what was the last slide which you have seen? Same. Okay. Thank you. Let me also put my charger because in the meantime it may go off. Just excuse me for a minute. Okay, we were discussing about the widespread concentration of fluoride in our country, and it occurs either naturally, through industrial contamination, and the long-term consumption can lead to this dengue fluorosis or bone fluorosis. Acceptable limit is 1, maximum limit is 1.5. Remedy, of course, is defluoridation and mixing fluorides, is intake of vitamins, etc. Types of fluorosis one can see. This is dengal fluorosis, and this is bone fluorosis, where scalical deformation takes place. Okay, is visible to all of you? Please confirm.
Yes, sir, it is visible. You continue, please.
Okay.
It's visible, sir.
Okay, thank you. Another important, contaminant in our society is arsenic. Actually, arsenic was initially found in Bangladesh, but in after studies on Bangladesh, India also started finding in our country, and initially it was observed in West Bengal, but later on it is found in many places in our country. Even the Ganga basin has arsenic concentration more than the permissible level. Arsenic occurs naturally in groundwater from arseniferous field. It also contributed through some agricultural insecticides. High arsenic concentration, of course, can cause various dermatological cancers, and it's a known poison, arsenic. Earlier, the acceptable limit was 0.05. But WHO has reduced the permissible limit to 0.01 milligram per liter, seeing its hazardous effects on human health. Another important conventional pollutant is a heavy metal, and heavy metals are discharged from industries like electroplating industries, in some refineries also, and they are also present as minerals in the rocks of the earth. And human activities, discharge of industrial wastewaters has resulted in the higher concentration of heavy metals in our country. In the city where I live, heavy metals are found in a high concentration in some groundwater. Why? Because we have lot many electrochemical industries, lock industries, and nickel polish industries. So there, what happened that they discharge their wastewater, many of them without any treatment. So when they discharge without any treatment, then it's going to affect our water supplies. Okay, so we have monitored the water in our many places in Aligarh, and the concentration of chromium, lead, nickel, etc. was found much more than the permissible value. And these heavy metals are known carcinogens. They cause cancers even at very low concentration. So we must have seen that 70% of the cancers are through these environmental contaminants. And in the last couple of decades, the death due to cancers are on an alarming rate. So this may be because of the effect of toxic things which are present in our water supplies. Why? Because the conventional treatment of water and wastewater does not remove such compounds. So if we talk of conventional water treatment, then this water treatment removes suspended solids, colloidal impurities like sedimentation tanks. It removes hardness like dissolved impurities, iron and manganese, and it removes disease-causing bacteria and viruses through chlorination. So this is a general conventional water treatment system in our country, which we have seen in various places. There are some instances where there are some specific pollutants, so the agencies are incorporating some specific units. Like in Yamuna, if you go to Sikandra, they have put an MBBR. Why? Because the BOG of the Yamuna water was very high. It was around 45 milligram per liter. So they have put an MBBR, moving back biological reactor. This is the only one MBBR in a water treatment, because MBBR is mostly used in wastewater treatment. So because of high BOG, they have used this. So 90% of the conventional treatment plant have above 3 facilities, and very few have some specific units that remove specific pollutants. Now let's come to the conventional sewage treatment plant or wastewater treatment plant. The primary treatment removes screenings, grades, suspended particles. And then we have a biological treatment system, the secondary system, which removes organic compounds. Then we have a tertiary system where wastewater is given disinfection for removing the pathogens. This is the only treatment which we have in conventional systems. The sludge treatment also there. This handles the sludges which is produced in the various units. Now you see the above units for water and for wastewater, they are not any specific unit which is there to remove the emerging contaminants. Now I'm going to tell you what are emerging contaminants. Many of you must be knowing, but the things to note here is that both conventional water and wastewater treatment units which are operative in our country, they do not remove these micropollutants or emerging contaminants. Please excuse me for 1 minute. I have to put my AC on. मैंने फैन ऑफ कर रखा है आवाज की वजह से. मैं एक मिनट AC ऑन करता हूँ. होल्ड करिए. Thank you very much. Am I audible?
Yes, sir.
Okay. Let's move ahead. Now, coming up to the emerging contaminants in water and wastewater. The things you see, pharmaceutical compounds are discharged in large concentrations from hospital wastewater, from expired pills, and also from human excretions. These drugs are discharged into sewage, and as I told you in the previous slide, the sewage treatment plant does not have any specific unit to remove such compounds. So I'll categorize these emerging contaminants into pharmaceutical compounds and personal care products, some nanomaterials, some pesticides which are also known as endocrine disrupting compounds or endocrine disrupting chemicals, EDC, and also we have disinfection byproducts, which I just forgot to mention here. Because if you are doing chlorination, then chlorine may form some compounds with organic compounds, like trihalomethanes, which are, many of them are carcinogenic. So our water supplies does not even monitor such compounds. Let me tell you, the Indian government or the labs which we have in Gillingham, etc., other departments, they do not have facility to analyze these emerging contaminants, because to find out pharmaceutical compounds, you need an LCMS. To find out these pesticides or EDC, you need a GCMS or an LCMS. So a high instrumentation facilities equipped with qualified technicians are required to monitor our water supply for such contaminants. What happens in our country that we monitor it for BOD, for COD, and sometimes we also monitor for coliforms, etc. But we do not care for all these compounds. which have a very detrimental effect on our human health. Background, mankind was benefited a lot from the discovery of new drugs. Every day, a drug is being discovered. Thousands of organic compounds are being, formulated or synthesized to make drugs for better living. However, these new compounds which are released to the environment are very fatal. Nobody knows what is the fate. The long chain organic compounds, nobody knows how they behave. Unless and until you have a specific compound, so you should know like how you can break up this compound to gases, etc. So this is a tragedy that okay, drugs are required for our living, but their proper management is essential. So hospitals are generally considered to be one of the important sources of emerging pollutants, which are resulting from diagnostic, laboratory, and research activities, and excretions from patients who are indoors, and also the components of the drugs and metabolites and residues of all these pharmaceutical and other things. So our hospitals, they have an incineration plant. Do you see the government policy? The government policy is that a hospital should have an incineration plant to burn the hazardous solid waste, but they do not make them manufacture a specific effluent treatment plant. Generally, most of the hospitals they connect their effluent to the sewer system, or when there are no sewer system, then they just dispose it off into the open drains and other issues. So this is a very important issue. The government should come up with some policy that every hospital should have its own EKP, so that they can remove these pharmaceutical compounds and other compounds also, which are causing a lot of health problems to the humankind. So, as I told you that the majority of these compounds are organic in nature, and they are long chain organic compounds. So most of them are non-biodegradable by the conventional method. Which, of course, if you have a USB or an activity research process or an interaction filter, it will remove BOD, and the conventional organic compounds will be removed. Nitrogen will be removed, but it may not remove these specific compounds which are generally non-biodegradable. So the treated wastewater, which we think that it's good from a sewage treatment plant, may not be good for our river, for our canal, etc., etc. Why? Because they will have such compounds, and which may result in the development of multi-drug resistance or antimicrobial drug resistance, resisting compounds to be formed. So apart from these, wastewater may have pathogens like this, as I told you earlier also, and the kind of chemicals and the kind of toxicity, carcinogenic, and also these case these reproduction rates are also affected. Many couples are having single child, or many couples are childless. So this we'll discuss later on why, because why this thing happens, why endocrine disruptors are there, and how they affect our human health. So emerging contaminants technology, that is a biological material or a chemical substance, maybe synthetic like drugs or maybe naturally occurring. And the most important thing that they are not routinely monitored in the environment. They are not routinely monitored in the environment. This is a very important parameter. Maybe they're in the environment, and they have a very long, half life. So they may be there for 40 years or 50 years. And governments have to think for future regulations that how we can control their presence in this water and wastewater. Examples, as I told you, maybe pharmaceutical compounds and personal care products, Among pharmaceutical compounds, antibiotics, hormonal drugs, statins, anti-cancer drugs. Of course, veterinary drugs are also used in large amount in our country. And in personal care products, sunscreens, colognes, antibacterial soap, hairsprays. And under endocrine disruptors, we may have like persisting organic pollutants like pesticides, chlorine-based pesticide, organochlorine-based pesticides like dioxin, pheromones, which are formed because of incomplete burning of solid waste. And then we may have disinfection byproducts, of course, with chlorine and as well as with ozone also. Ozone also forms some byproducts. And of course, brighteners in detergents and antibacterial nanomaterials. They're all emerging contaminants which are unfortunately not monitored regularly. Now, the occurrence of these drugs have become a major concern in America. They are doing a lot of research on this, and what they have seen that one of the effect of high intake of antibiotics among the youth is that it has decreased the adolescent age. The adolescent age has decreased, and they have linked this with the consumptive use of antibiotics in the water supplies which are present there. So they may be introduced as a result of inefficient removal from sewage treatment plants or disposal from pharmaceutical based industries. And they have been detected in surface waters, in wastewaters, in large countries. India also, a few people have done some monitoring of our rivers. In Ganges also, they have found in the upper stream a lot number of antibiotics and this metrogyl and etc. Like hypertensive drugs also they have monitored. They are present there. So pharmaceutical compounds comprises of family consisting of antibiotics, analgesics, beta blockers. Of course, they are all used for control of blood pressures. 1 in 4 youth is suffering from blood pressure, so they are taking these drugs regularly. I am also taking drug regularly for blood pressure. Lipid regulations also we use alternative type of tablet. Towards again compounds are used. Anti-cancer drugs are very much in use in cancer hospitals. And another very important and widespread uses of antidepressant drugs. Many of our youth are suffering from depression and they are taking a lot of medicines for this overcoming this depression. So ultimately they find their way in our water supplies through sewage, and these drugs show variation in biodegradability, in volatility, in solubility, absorbability, and stability. And that's why they are not. It's very difficult to remove them in a conventional sewage treatment plant. And many of the drugs which may have synergistic effect or antagonistic effect. Synergistic effects, of course, is a harmful effect. So now active pharmaceutical compounds have major concerns. As they can interfere with our biological activity and can lead to very dangerous consequences. So it is estimated that approximately half of the pharmaceutical wastewaters produced worldwide are not given any treatment. They are discarded, and that's resulting in the presence of these compounds in the river. This one of the table which shows the name of the drugs and the class. And antibiotics, erythromycin, fluoxetine, ciprofloxacin, penicillin, sulfamethoxazole, amoxicillin, etc. Among steroids, you have estradiol, estrons. These steroids are also endocrine disruptors. Let me tell you, many of these steroids are endocrine disrupting chemicals. They interfere in our hormonal systems. Anti-cancer drugs, diuretics are used very commonly. Antidepressants are very used commonly. And many people are taking tranquilizers like diazepam, etc. And beta blockers is very common. Ethanol, propanol, I mean, these are all salts which are there and available in the market. And lipid regulators are also used. And apart from this diclofenac and ibuprofen, these are found in large concentration in various waters and wastewater. So if you see this picture, you can see the source of these pharmaceutical compounds in our wastewaters. How it comes either from hospital waste or from human excretions, and they all go to sewage treatment plant. Some of the industries producing these pharmaceutical compounds, they may also release these compounds in their effluents. And apart from this, we have veterinary drugs which are there, which maybe they are in the manure, which go to fields, and from agriculture runoff, we go to surface waters, and ultimately, the sewage treatment plant also discharges its effluent in the surface waters. So, and some of the surface waters, may percolate, give down to have occurrence in the groundwater also, in the first stratum of the groundwater also. So, we cannot say that the groundwater is safe from such emerging contaminants. Groundwater may have some emerging contaminants also. Okay. So this picture is clear to you or not? Yes. Any one of you?
Hello. Yeah, Dr. Farooqi.
This picture is clear?
Yeah, everything is going perfect.
Okay, thank you, thank you. Another source of these pharmaceuticals, how they can find way in our surface water and groundwaters, basically from these human excretions and pharmaceutical industries, and also from the landfills also. The landfills, it may go up to underground water also. So this is the maximum reported concentration of different pharmaceutical compounds which are present in India, North America, and Europe. And you can see that the concentration are in micrograms per liter, not in milligrams per liter. But you see, ciprofloxacin in our country, 31 milligram per liter, 31,000 microgram means 31 milligram per liter is a very high amount. Why? Why? Because in our country, more than 50% of the doctors, they are practicing doctors are non-qualified. So if any patient comes with any symptoms of any cold and cough or fever, they start giving antibiotics immediately. But in other countries, in advanced countries, they wait for 2 to 3 days then antibiotic. Though the private practitioners, uh, they are responsible for giving more and more antibiotics. You see, ciprofloxacin was one of the very old, I should say, very old antibiotic, but and very safe also. So this is being given to large patients, and the concentration was found much as compared to other things. Azithromycin is there. So we can see that in our country, the concentration are much more than what is in North America and Europe. And this is concentration in the inlet of the sewage treatment plant. This is not in the surface water, this is in the sewage. The sewage which comes to the sewage treatment plant, it has the concentration of drugs this much amount. And as I told you that we don't have specific units to remove these compounds. So naturally they will be there in the effluent of the sewage treatment. So a large amount of this have also been collected in the surface waters. Or in India, we are very unfortunate that we have done very less monitoring of our rivers for such compounds. So we don't know the status of the quality of the river. We all, only what we do, we to find coliform, so we find BOD or we found suspended solids, and we are satisfied that BOD is less and so and so. No, we have not found any such compounds. We do not find these compounds in our water supplies. So what will happen? Like our rivers may have such compounds, and from rivers it goes to water treatment plant, And the water treatment plant, these compounds will escape this plant. Why? Because we don't have special units, and to water distribution systems, it's been consumed by human being, and we get an intake of all these compounds. So this is the route through which we are exposed to these compounds. So is there any concern? I don't see any concern in my country. Although in the US, in some European countries, there is a lot of concern over these pharmaceutical compounds, and they have, incorporated various tertiary treatment systems to remove such compounds. Endocrine disruptors are substances that mimic a hormone in the endocrine system and that affects or disrupt the function of our hormones. So these are the effects of this. And potential endocrine disruptors are, this organochlorine-based pesticide, DDT, bisphenol, which are used in plastic bottles. We have a tendency, to keep our this mineral water bottle in the fridge for 6 months or 1 year. We used to refill it, but we don't know the side effects of these compounds. And these estrogenic substances like birth control pills, which are also used in a large concentration in our country. So they are all the phthalates which are used in toys and air fixtures, fire retarders. You must be knowing a very interesting story that there was a halon gas which was there in advanced countries used to extinguish fire. So when they did the research, they found that it has got potential endocrine disruptors chemicals. So they have discarded this, and what they have done, they have shipped it at a very low cost to developing countries. And in India, one company came up and it has given you fire retardants from that very gas. So this is what happens that we do not have much awareness about it. And I should further categorize these endocrine disrupting chemicals as persisting organic pollutants, like the organic pollutants which persist in the atmosphere for a very long time, and they can also bioaccumulate through our food chain. And another thing is that they can be transported to large distances through wind because most of them are volatile, so they come in the atmosphere and they can be driven off with the wind to long distances. Today, these persistent organic pollutants are found everywhere in our food, in our vegetables, in our air, in our water. The characteristics, they are very toxic, persistent. Persistent means they are non-biodegradable. They will live in the atmosphere for a very long time. They are bioaccumulative in nature, long transport through air and water currents. And this is the biomagnification of PCBs. You see what happens that when you spray such compounds in a water body, some small insects can tolerate up to this amount, 0.00002 ppm. So some large phytoplanktons can consume a large amount of this, and the concentration of this toxic in this phytoplankton can be 0.0025. Now, these phytoplanktons can be in turn eaten up by the zooplanktons, and the zooplanktons will have an increased level of this PCBs around 0.123 ppm. So we have started from 0.00002 ppm, and now we have reached to a state of 0.123 ppm. Further, if these zooplanktons are eaten up by fishes, they will have 10 times concentration around 1.04 ppm. And suppose these small fishes are eaten up by large fish, then it will have concentration around 5 ppm. And of course, if some large bird comes and they eat this fish, it may have concentration as high as 124 ppm. And when it hatches, legs, when it give eggs, lay off eggs, and then this eggs will have those concentrations. So this is just a cycle through which we can see that how PCB is another endocrine disrupting chemical. It can be magnified. One story, all of you know that this DDT was, invented for killing this malaria mosquito, and the person who has synthesized this got Nobel Prize. But he didn't know that after so many years, this compound will be banned. No, it is banned worldwide. Why? Because it is it can be biologically magnified through the food chain. It is a persistent organic chemical, so it is no longer being used these days. So hazards, of course, it damages our nervous system. It decreases our immunity. This is a very strong point. Our immune system is affected by these endocrine disruptors, reproduction and developmental disorders, cancers, and most of them are endocrine disruptors. That is, for disease like thyroid and sugars, which are hormonal based, there is no age. It can occur in any age. Likewise, among emerging contaminants, we may have some personal care products which we use daily. We don't know they are also organic. They have uh, this disinfectants which we spray in our kitchen. They are all very harmful. I never use any Hig etc. in my house. For last 10 years, I have not used this Begon or Hig. Why? Because I know that it is a harmful chemical and it can come to the environment in the air which we breathe. So I always advise people not to use this. And other personal care products are also there, but their concentrations are found in less amount in water supplies. So where these compounds are commonly found in our countries and Asian countries, let me tell you, they are not being monitored. So wherever they are monitored, they are found. In Europe, in Canada, in USA, in some parts of developed Asian countries also, people have analyzed their surface waters and they have seen the presence of all such compounds. Okay, so 80% of the all compounds which they have tested become positive for all these compounds. So this is the map that shows where these are present. Now, in USA, their water supplies have targeted some compounds based on pharmaceuticals or endocrine disruptor chemical, hormones, and phytoestrogens. And they have just seen that the compounds which have more adverse health effects, and they have set them as the target compounds for monitoring in the sewage treated effluent as well as in the water supply. So first they have found in their raw water. So the compounds which are in bold, they are present. They have found these compounds are present in their raw water. And in the US drinking water supply schemes, the finished water which is being supplied to consumers. So they have analyzed and they found that the concentration of these drugs and other emerging contaminants were in this range, in nanogram per liter, like atrazine X70. But these three compounds were in higher amounts: KCPP, KCEP, and atrazine. Otherwise, the rest of the compounds were because what they have done, they have incorporated various units. I'll show you in the later slides what they have done. Then disinfection byproducts like trihalomethane. You can see here. This is a common compound which is formed. Haloacetic acids and trihalomethanes are the major classes of disinfection byproducts which are formed in the water and wastewater, which are disinfected with chlorine. Chlorine is supposedly the most common disinfectant which is used worldwide. And if it is not used, in a very decisive manner, then it may lead to formation of these compounds. But we have to monitor the water for such compounds before we finalize the dose of the chlorine. So the chlorine dose is generally, you know, is decided by this breakpoint chlorination, which all of us know. We have studies in the 12th class, in the first year engineering also. And this is the region where organochlorine compounds are formed, or trihalo compounds are formed, which is a combined chlorine residue. But if we, give more and more chlorine, then they will be destroyed. So we have to see how they can be destroyed to nitrogen gas. So classification of trihalomethanes in chloroform, bromogichloromethane, dibromochloromethane, and bromoform. And you can see that the classification, they are possible human carcinogenic group 2b, and the first two one are possible human carcinogenic, but the last two have not been identified or classified as carcinogenic for humans, though maybe carcinogenic. So the effects of this US EPA cancer potential factors, so they have given you the potential factors, cancer causing potential factors of these compounds. So for chloroform, of course, there's no sufficient guys available. For bromo dichloromethane, it is 0.062 milligram per kilogram of the body weight per day. If this much amount is taken per day, then it is, of course, a potential cancer causing concentration. Likewise, they have also given for this dibromochloromethane and also for bromoform. So one has to analyze the treated wastewater for this disinfection byproducts also, which we are not doing. We are not analyzing such compounds. So the major thing is that we don't have specialized technicians and we don't have specialized equipment. We have a specialized lab like CSIR labs are there where they have equipment facilities, but very few government organization they go to those places to take their samples analyzed. Uh, One story which I would like to share before sharing this line. Like I'm a member of this rural water supply scheme, and the meetings held generally occur in Lucknow, and where chief engineers come and they say that their water has arsenic and fluoride, so that's why they want that the scheme should be given proper treatment and so and so. So I've asked this question to the principal secretary directly. I told him that it is not easy to find arsenic by the Jal Nigam lab. So when I inquired, so they told me that they have a kit, 3,000 rupees kit, which shows the presence and absence of these compounds. So this is such a large racket that lakhs of those kits were being sold for monitoring. When I told him that do not rely on this data, get water samples tested with some standard laboratories in Lucknow like ITRC or CGRI. I also offered my institution, AMU, as we have atomic absorption spectrophotometer for determining arsenic. But they were recommending that they have to spend so many thousand crore of rupees which they have borrowed from World Bank, and every village should have a tube well and a overhead tank and a distribution system. So 70% of the villages in our countries have been covered with this rural water supply schemes, and another 30% are in progress. But they don't know how to monitor these compounds, arsenic, etc. So I told you that it is done through either ICP or through this atomic absorption spectrophotometer. Okay, coming back to this, the various advanced countries have incorporated a specialized treatment system based on advanced oxidation processes. So if you're using UV as one of the advanced oxidation processes, then the results are that these compounds are removed to less than 30%. These compounds are removed in the range of 30 to 70%, and none of the compounds is removed more than 70% if you are using UV alone. Now, if you are using chlorine and with a 3.5 milligram per liter and a 24-hour exposure, 24-hour exposure is a very high exposure. Generally, we have this 30-minute exposure in our treatment plants for chlorine. So, less than 30% of these compounds are removed. This is the range of 30 to 70, and more than 70% these compounds are removed with chlorine. Okay? And of course, given 24 hours retention time, which is a very high retention time, you need a very large chlorine contact tanks. Now, coming on to another group of advanced oxidation processes, either we are using ozone or we are using UV in combination with H2O2. So there we have seen that large amount of the compounds are removed more than 70%. The best thing is, of course, RO, but reverse osmosis is a very costly affair. It's a very, very costly affair. If you are having a 100 ml plant, the maintenance cost is very high. So do not go for this. Go for the combination of advanced oxidation processes and have facilities to, online monitor such compounds. So what are reuse facilities after disinfection, This is a wastewater effluent, this is a membrane filtration effluent, this is the RO effluent, this is the UV combined with other advanced oxidation process effluent. You can see that we are able to reduce here. The white zone shows how much efficient these processes are for removing this. Otherwise, a conventional wastewater effluent has so many compounds, and membrane filtration also has so many compounds. But as I told you that this is a very costly affair. The maintenance, of course, is very costly. In our countries, we may not be doing, but in the US, they've been using for last many years these RO plants in our their drinking water systems. So, but this graph shows you the energy consumption also. Hmm. The the compounds which we have removed there, and you see this RO, UV, AOP, they require maximum energy, so many kilowatt hour per meter cube of water treatment. So we have to see also this thing that if you see this cycle, more energy means more greenhouse gas emissions and more drug drought or increase wastewater disposal on groundwater. Things like everything is interrelated, but we have to go for the lesser level. Another emerging pathogens which we see, we have discussed, like fecal contamination of water supply is one of the major source of pathogens, and open defecation was in our country followed some times back. Nowadays, our country is free from open defecation, and that's why the water quality may have improved a lot. So now coming up to this coronavirus, it has been detected in the feces of infected patients in the wastewater. So many countries, what they have done, they have analyzed the wastewater of that community for this coronavirus, and if the wastewater was having this, so indirectly they say that that community will have infected people. So this is one of the indicator of infection of people with coronavirus that they discharge in their feces. So if we monitor the sewage of that area, and if the sewage is having this, so we can say that that population will be having coronavirus infection, and that's why this is sometimes used as wastewater-borne epidemiology. Epidemiology, wastewater-based. So for these applications, we may use this characterization of sewage for this coronavirus. So we can say that the concern regarding transmission of virus in the environment from this sewage, it may go to recreational water like fountains, etc. From there, it may come into aerosols, which may inhale. Hospital wastewater, as told you earlier, also it's one of the main culprit of all emerging contaminants and even emerging coronavirus also. So the hospital which are treating COVID-19 patients should have facility to disinfect their hospital wastewater before they transport it to some other places. So this is a serious issue, and we can say that about 20 to 40% of the infections are symptoms of diarrhea, and which is capable of binding to receptors in the intestines as well as to lungs. And it was also observed that these viruses may be detected in the urine and the stools of the infected individuals even after 100 days of their initial infection. Now, if they are cured, they are discharged or they are discharged from home isolation, even then for 3 months or so, they may discharge this virus. So I'll advise each one of you, do not use public commode system, because this Western commode system is one of the major causes of infection through fecal contamination. So even if you have somebody in isolation in a house, so you give him his own tonic for 100 days because he may be discharging like coronavirus for 100 days even after becoming cured. But the positive side of this is that the persistence of this virus in a sewage is 2-3 days only. It's not very persistent. So what we can do, we can separate the sewage from isolation wards, and we can give a good quality disinfection. So chlorine, of course, has been found to be active in destroying this coronavirus. That's why people are using, disinfection or sanitization with sodium hypochlorite. Although sodium hypochlorite is less efficient as compared to bleaching powder or correct liquefied chlorine which we use. But it is more resistant to water treatment than other microorganisms. However, recent studies have shown that the chlorine can be used to destroy them, and the survival, of course, become less at lower temperature. Sorry, at high temperature, because that's so disinfection of with chlorine is one of the best thing, and the recommended dose is that either you use 10 milligram per liter of sodium hypochlorite for a contact time of 30 minutes. But the free residual should be more than zero point 0.4. In water supply, we see that the free residual chlorine should be around 0.2 milligram per liter. But for wastewater, which are likely to have these coronaviruses, the residual chlorine should be more than this. Why? Because this residual chlorine, they prevent the regrowth of these pathogens. So this can inactivate 10 to the power 5 numbers of coronavirus. The level of chlorination, of course, in should be free. I told you in Canada, zero point 0.5 milligram per liter free residual chlorine. The efficacy of UV disinfection is depending upon various factors. But you see, the government which are using sodium hypochlorite, is good. Chlorine is found very good. Now, luckily, we have seen this paper. Last year also, I have seen this paper. Like it has a low stability in environment, and it is very sensitive to oxygens like chlorine. And just hold a minute. 5 मिनट हो गए हैं तुम चलिए अब। So it can be inactivated efficiently. Temperature is an important survival factor, and it declines more rapidly when temperature is increased from 23 to 24, etc. And there is no evidence that human coronavirus are present in the surface of the groundwaters or are transported through contaminated drinking water. There is no such source availability. That is good sign for us. But let me tell you the thing which have happened. A very unfortunate thing happened in our country in the past couple of weeks. That a lot of deaths have occurred. And before thanks, I'll show you a few slides. All of you must have seen large amount of cremations near our holy river Ganges, dumping of bodies in rivers, floating of bodies in rivers, and this is again burial of human bodies in near the banks of the holy Ganga. Government is spending a lot of money for cleaning this holy river, and you see such activities. Of course, it is very unfortunate that large amount of deaths have occurred, and this crematoriums, electric crematoriums for short were very few, and even the wood became rare. People were not finding this wood to burn their bodies out there. Though they have been compelled to float them in river or to bury them like this. So whenever some flood occurs, then flood may, carry all these bodies. What will happen then? Yesterday I was listening to a news and it was saying that 400 to 500 bodies are being, brought every day on Sangam in Allahabad. So we must pray to Almighty that this pandemic must end. Otherwise, our river Ganges, the quality is in danger. And we'd like to see the authorities the government should ask this National Mission for Clean Ganga, NMCG, to aid people in cremating the bodies, to give some grants so that bodies are not being buried or not being floated, which destroys the water quality. NMCG has a lot of funds and they are being funding the various projects. So they should think once that this way also they should come up and they should see that people who have lost their life, they should be given a standard cremation. And I dedicate my lecture to those who have lost their life in this pandemic and they are no more with us. Okay, this was all. Any questions you want to ask?
Okay, so thank you very much, sir, for this alarming lecture. Really, it was a very awakening lecture for giving an insight of the issue. And I was really amazed to see few points you addressed so well in your session, like pharmaceuticals, solid waste, heavy metals, hospital waste, beauty products, disinfection byproducts, endocrine disruptors, their causes and effects, and also the advanced technologies, solutions for the prevailing uh, emerging contaminants in water and wastewater. Thank you very much. It was really enlightening to hear you, and I'm sure our future researchers, scholars, and students must have been benefited. Now I request my co-chair to start the question answer session. Please, come on.
Okay, thank you. Thank you very much, Professor.
Yeah, Dr. Farooqi, can you just stop sharing your screen? Perfect. So now we can see you. Yeah, good.
Thanks a lot, sir, for your valuable time.
Okay, thank you very much.
It's been a pleasure, sir. We have
So
some
I'm
questions.
I'm available on my phone also. Any participant, anytime can ask me any question on my WhatsApp number. My phone number is there on my AMU website. So I receive many questions, many queries on my WhatsApp, and I try to answer all of them. So all participants they are requested whenever they have any confusion, they can freely send me a WhatsApp message. I shall try to reply them.
Thank you very much. Thank you very much, sir.
Okay.
We have the first question as
Arshad Hussain, are you there?
Yes, sir, I'm there. I want
Okay.
to ask a question also, if you permit me.
Sure.
So I've seen in the newspapers that in Delhi or in the area surrounding NCR region, there have been cases reported in the multi-storied buildings where they share the common sewage lines between the flats in several stories. So there have been cases that people are isolated in their homes and yet they have got the COVID infection, and that has been attributed to the water closets or the commodes that have been you have been just mentioning in your lecture. So is it
Yeah.
possible? Is it possible, sir?
Like because basically through oral fecal contamination.
Okay.
If you are sharing the same commode or what happens then in multi-story building, sometimes the sewage from higher floors come to the lower floors in systems through this pipeline. Some siphoning action occurs and the wastewater is backflowed in the toilets of some other building. So if that happens, then the virus will be there on your commode. Wastewater will go up, but the virus will not go. And if a person sits, on the commode, and he may get infection.
Okay, thank you very much. Very informative lecture, sir. Thanks a
Thank you,
lot.
Ashit.
Yes, sir. Can I provide you the questions?
Sure, sure.
Yes, yes. Bukhari, come on.
Sir, sir, we have the first question as from Anil Singhai. He says that, sir, can you provide in brief about some legal provisions related to medical waste disposal, sir?
So in our country, as I told you, that we have a legislation that if your hospital is having so many beds, then you should have an incineration plant to burn your hazardous solid waste. But there are no regulations on the effluent of liquid effluent which is produced from hospitals and nursing homes. Till now, there is no such legislation. They are discharging in their sewers.
Thank you, sir. Another question is, how can you detect the presence of, say, chlorofluoxetine in wastewater? It's from Shavalana.
We can use this technologies what we call LCMS. LCMS is an equipment which can be used to detect such compounds in water and wastewater. Liquid chromatography mass spectrophotometer, LCMS.
Thanks a lot, sir. We have Dr. Murmuri Saho asking, good afternoon, sir. It's an informative session. Her query is, please suggest that should we consider these pharmaceutical waste while calculating water quantity in indices? If yes, how much weight can we give to these antibodies and analgenesis indicators?
Just can you repeat the question?
Definitely, sir. So her question is, please suggest that should we consider these pharmaceutical wastes while calculating water quality indices? If yes, how much weightage can we give to these antibodies or analgesics indicators?
Actually, no. Uh, in water quality indices, we have yet not, incorporated these emerging contaminants globally because their concentrations are less. They are in micrograms these days. But once they become very commonly analyzed in waters of all countries, then globally we may come up with some regulations that so much amount of if so much amount of this antibiotics is there or analgesic is there, then we can accordingly redefine our water quality index. But right now we are not using those emerging contaminants in water quality indices.
Thank you, sir. We have another question from Mr. Sachin Kumar. He says, sir, can you please mention few tertiary treatment for removal of these pharmaceutical emerging contaminants?
People are doing research on this, and biological treatment may not be very suitable in this. So we may have to go for 2 to 3 stage treatment. Some compounds can be removed anaerobically or biologically through anaerobic treatment. People have seen this, and then we have to follow it with some advanced oxidation processes. Like we may have to go for this combination of UV or ozone or Fengton process or photofengton. People are doing a lot of research these days, and a couple of my students are also doing PhD on the biodegradation of these pharmaceutical compounds. But the conventional biological treatment system cannot remove this. We have to have some advanced oxidation process, and that too maybe in combination, not once, but not proved. And in many countries, ozonation is being used as a last process, and this ozonation can remove many compounds. But what is required that continuous online monitoring is to be done when you are having such a facility in your sewage treatment plant. Why? Because we have online this LCMS or things like that, or HPLC, online HPLC is there, where they can give you directly the values of these compounds which are present in the liquid. So people are doing a lot of research these days, and the process may be specific for a specific drug. Let me tell you. For organo-based chlorine pesticides, which are endocrine disruptors, some anaerobic treatment systems are found to be effective, which can produce enzymes that can degrade the bond between this chlorine and other organic molecule. So we have to develop some new strains of microorganisms. We have to create conditions, we have to create acclimatization criteria for removing such compounds.
Thanks a lot, sir. Mr. Kundan Verma asks if there is any alternative disinfectant than chlorine.
Yeah, there are a lot of, as I told you, ozone is here, and this ultraviolet rays are there. And the best one is RO, reverse osmosis. If the membrane size is less than that of a virus, then nothing is better than that. But that is very costly, and that will also remove all your minerals, which are essential for body. These days we are using RO water, and RO water, has removed lot of minerals, so that's why our body is not having sufficient calcium, potassium, and other minerals. So this is one of the drawback also. But generally, chlorine, liquefied chlorine is gas is being used in our country, and chlorine is of course very effective. But we have to monitor it for disinfection byproducts. Ozone also forms bromates, which are disinfection byproducts. But ozone is costly than this chlorine. Chlorine is cost-wise economical as compared to ozone. But many small institutions, they are using ozone as a disinfectant.
Thanks a lot, sir. With the time approaching, I may have the last question in here for you, sir.
Sure, sure.
Mr. Pooja Sinha says, what could be probable reason for springs of Himalayan region having no E. coli for microbial analysis, but high colonies of MPN, but also having high concentration of nitrate, say more than 45 milligrams per liter?
Which water? Himalayan?
Himalayan, sir. I may repeat the question.
Okay.
The question is, sir, what could be probable reason for springs of Himalayan region having no E. coli for microbial analysis, but high colonies of MPN, but also having high concentration of nitrate, say more than 45 milligrams per liter, sir?
Okay, nitrates may be there because of uh, springs may have some underground source, and but MPN is there and E. coli is not there. This is not very clear to me because E. coli is in the family of MPN, I think, if my knowledge is right. If E. coli is there, then if MPN is there, then E. coli is bound to be there. But also E. coli is one of the indicators. But springs, how they may have those E. coli unless and until they have fecal contamination. As far as nitrates are concerned, many springs are having inorganic compounds which are from the minerals which are there in the underground waters. Underground waters, they appear as a spring whenever they found any impervious stricum. So nitrate source may be there from the underground source, maybe there. I'm not sure about it. I'll inquire. I'll just go through it and may answer you if you send me an SMS.
Definitely, sir. Thanks a lot. And I thank each and everybody to putting up the queries in the question box. Thank you very much, sir, for taking up the queries of our audience on behalf of SCE, Lovely Professional University, and from the entire team of faculty members and students. I am thankful to you for spending the time with us. We wish you all the good health and prosperous life ahead.
Okay.
Thank you once again, sir.
Thank you very much to the organizers. I would like to place my thanks to Professor Amit Srivastava, Dr. Pushpendra Sharma, and Khabab Bukhari. Thank you very
Welcome,
much.
sir.
Yeah, thank you, Dr. Farooqi.
It's
I
been a
think,
pleasure, sir.
can you see this certificate?
I can see.
As a
I can
token
see.
of appreciation from our side.
Thank you very much. Thank you very much.
I'll be sharing this through email. And
Okay. Okay.
I once again thank you very much for sharing your valuable time with
Thanks,
us.
doctor.
And
We will have
sharing
interaction in future also. Okay.
Yes, sure.
Okay.
Thank you.
Sure. Thank
Thanks,
you
sir.
very much. Thank you. Okay.
So